All right, let's talk about one of the most important parts of machine learning. See, AI models, they're hungry. They need just massive amounts of data to get smart. But all that data has to live somewhere, right? And picking the right home for it on a platform like AWS is one of the biggest decisions you'll make. Get it right, you're golden. Get it wrong? Well, you're looking at huge bills and slow models. So let's dive in and figure out how to get this right. So let's start with the big question that's on the screen. We know AI runs on data, but where does it all actually go? It's not as simple as, just saving files to a folder on your computer. We're talking about everything from nice, neat customer records in a database to just mountains of messy, unstructured video files. And yeah, each of those data types has totally different needs when it comes to scale, speed, and safety.
And that right there brings us to our first huge challenge, the scale problem. I mean, just try to imagine storing every single photo, video, text message, and log file your app is ever going to create. You need a system that can handle a practically unlimited amount of this stuff without you having to constantly worry about buying more hard drives. That'd be a nightmare, right?
So the really smart way to solve this is with an idea called object storage. You know how files and folders get super messy and complicated when you have millions of them? Well, object storage just throws that whole idea out. Instead, it treats every single piece of data, a photo, a video, whatever, as its own little self-contained object with a unique address. It's just this flat, super scalable way to store, well, pretty much anything. And on AWS, when you hear object storage, you should immediately think Amazon S3. Honestly, the best way to picture S3 is as an infinite digital filing cabinet. You can stuff anything in there as much as you want, and it's just there, safe and sound. It really is the bedrock, the foundation for so many machine learning workflows. Okay, but think about that filing cabinet for a second. In a real office, you don't treat all your files the same, do you? You've got stuff you need right at the front, things you pull out every single day. Then you've got those old records in the back that you might look at once a year, maybe. If we paid top dollar to store everything like it was super important, we'd be wasting a ton of money. So is all data accessed equally? Of course not. And this is where S3 gets really clever about saving you money. It gives you different storage classes, which are basically just different kinds of cabinets for different kinds of data. For that stuff you need right now, like an active training set, that goes in S3 Standard. Think of it as the drawer right in your desk, easy access. For less used data, there's Standard IA. That's the big filing cabinet down the hall. And for the real long-term archives, like model backups, that's S3 Glacier, the deep, deep archive in the basement. Getting this right is absolutely key to keeping your costs down. All right, so we've tackled scale, but what about speed? S3 is fantastic for holding onto those huge data sets, but when you're in the middle of actually training a model on a cloud computer, you need something that acts and feels like a local hard drive. You need something blazing fast with almost zero delay for all that intense reading and writing that happens during training. And for that, the answer is Amazon EBS, which stands for Elastic Block Store. The easiest way to think about this, it's literally a virtual hard drive. It's a high-performance disk that you just click and attach directly to your EC2 cloud server. This is where your operating system lives, it's where your applications run, and it's where you put data that needs that immediate, super fast access while the computer is chugging away. Okay, so this is a really important distinction to get right. S3 versus EBS. Remember, you access S3 over the internet. It's like a giant shared network drive. But EBS, that's attached to one specific server. It is that server's C drive, its own personal hard drive. So the workflow is simple. You store your big, raw data sets in S3 for the long haul, and you use EBS for the fast, active, heavy lifting part of the job. Okay, we've got scale covered with S3 and speed with EBS. But what about safety? I'm talking about your most critical, structured data. Customer information, transaction records, the kind of stuff that usually lives in a good old-fashioned database. For this kind of data, our number one concern is making sure it is always available. We simply can't afford for it to go down. And for that problem, AWS has an incredible service called Amazon RDS, the Relational Database Service. My favorite way to think of this one is as a smart, self-healing database. What's great is that it's a managed service. That's just a fancy way of saying AWS handles all the annoying, tedious stuff for you. The patching, the backups, making sure it stays online. That way, you can just focus on your actual data, not on being a database administrator. So let's talk about why this is so important. If you've got your database running in just one physical location, what AWS calls an availability zone, or AZ, you're basically walking a tightrope. If anything happens to that one data center, a power cut, a network glitch, anything, poof, your database goes down with it. That's what we call a single point of failure, and it's a huge, huge risk. But this is where that self-healing magic of RDS comes into play. With a feature called Multi-AZ, RDS is smart enough to automatically create an exact live copy of your database, but in a completely different physical location. Every single change you make is instantly copied over. So if the main one fails, RDS just automatically and seamlessly switches over to the standby. You don't have to do a thing. That's what true high availability looks like, built right in. Now, when you get into disaster recovery, you're going to hear two acronyms thrown around a lot: RPO and RTO. Let's start with RPO. That's Recovery Point Objective. Don't let the name scare you. It's really just a simple question. In a total disaster, how much data are you okay with losing? Can you afford to lose the last hour, the last day, or nothing at all? Your answer drives your whole backup plan. Okay, so that's RPO. The second one is RTO, Recovery Time Objective. And this one is all about how long you can be offline. After something breaks, how fast do you need to be back up and running? Can your business survive being down for a few hours? Or do you need to be back online in like 2 minutes? It's all about your tolerance for downtime. So how does RDS help us with that RPO question? Well, it does something really cool. It's constantly backing up what are called transaction logs to S3. And because of that, RDS can get you a recovery point objective of just 5 minutes. Think about that. It means in the absolute worst case scenario, the most data you could possibly lose is 5 minutes worth. For most applications, that's absolutely incredible. Okay, let's bring it all home. We've talked about the 3 big problems and their solutions on AWS. We've got the infinite filing cabinet for massive scale, the virtual hard drive for incredible speed, and the self-healing database for bulletproof safety. So now, let's put it all together into a really simple cheat sheet that you can use for pretty much any project. Here it is. For Amazon S3, think Infinite Filing Cabinet. This is your go-to for storing huge amounts of unstructured data and all your backups. For Amazon EBS, think Virtual Hard Drive. This is the high-speed disk you attach to your servers to actually run your apps. And for Amazon RDS, think Self-Healing Database. You use this when you have that critical, structured data that absolutely must stay online and protected. So you see, data storage, it's so much more than just saving files. It's literally the foundation of your entire machine learning strategy. Every choice you make here is going to ripple out and affect your cost, your performance, and how resilient your system is when things go wrong. So the real takeaway is this. Go back and look at your own projects and ask that one simple question. Is my data in the right home? Thanks for tuning in.